Hello, this is Fred Kennedy at Diablo Valley College, Pleasant Hill, California. Today I'd like to talk about a shifter circuit, a left shifter circuit. This particular circuit will shift 4 bits. If you wanted to shift 32 bits, you'd need 32 of these guys. So what's going on here? Well, this is the enable line. 1 means shift, 0 means no shift. Let's put some simulated bits in here. So bit 3 will be 1, bit 2 will be 0, bit 1 will be 1, bit 0 will be 0. This ground symbol on the right here, I think you remember the basic shifting left lesson, where if you're shifting bits to the leftmost bit goes into the carry flag, and the rightmost, and on the right it fills in with zeros. That's what this grounding thing does. This circuit does not illustrate shifting the leftmost bit into the carry flag. So let's go with the situation where the enable line is 1, which means shift. So if 1 comes into the NOT, becomes 0. And this 1 comes down here, but 0 and anything is 0. And then we have this 0 here for bit 2 coming down into the AND. And we know that 0 and anything is 0, so it doesn't matter what the other input is. So that's 0. Then we have 0 or 0 and the output 0. So this bit 2, which was 0, was shifted that way. Now if we go to the next spot here, enable line of 1, not it becomes 0, 0 and anything becomes 0, it doesn't matter what this is. And then we have this 1 over here, bit 1, which we're trying to shift. It comes into the to the AND. And we have a 1 here for the enable. 1 and 1 is 1. 1 or anything is 1, so we have 0 or 1 is 1. So that's the shifted bit. It was bit 1 here. Then we shifted it left, so now it becomes bit 2. So now we have the next situation for these 2 bits. Bit 0 would be the shifted bit, bit 1 would be the non-shifted bit. So if bit 1 is 1, 1 comes into the AND, but we have the 1 enable. Goes through the NOT, becomes 0, 0, and anything is 0. And then we have this 0, bit 0 coming in down here, 0 and anything is 0. So 0 or 0 is 0. So we've shifted this 0 to the left. Finally, we have the rightmost circuit here for the rightmost bit. We have 1 coming in as the enable bit, 1 knotted is 0, 0 and 0 is 0. Well, 0 and anything is 0. And then we have the grounding here, which is 0, represents 0, so 0 comes in here, and this is 0. So we have a 0 here, 0 and or 0 is 0. Now it's possible to program the circuit by programming one of these subunits. And we could program this to be called, if we want to shift 32 bits, we would put this in a loop and call it 32 times. And that is how a left shifter circuit works.